Polytechnic University of Valencia and President Spancold, Spain. Also as our co-chairman of this session, Mr. Ijsbrand J. Young, Lead Water Resource Specialist from World Bank, USA, and the rapporteur of this session, Dr. Hadush Sagad Hagos, from the Central Project Management Unit, Central Water Commission, India. I would start this session by requesting our session chairman for his opening remarks, as well as request him to present the theme paper on recent international examples of the added value of risk assessments in dam safety. Thank you.
Okay. Please make sure they do. Good morning. It's my pleasure to be on the podium again to chair this session, and I welcome all the audience to enjoy this very well-balanced, in my opinion, set of speakers. You're going to hear about the benefits, the limitations, the case studies, the past, the present, and the forward of risk assessments, and every one of you will make your own conclusions. So from the table, we are not going to tell you what to think. We are going to expose you to different experiences and thoughts, and it will be your responsibility to make your own conclusion in a way. So the other thing, we've been told that we have to be extremely careful with the timing. So we will be planning to set up to cut the session by 12:25. So I'm going to save a little bit of the time in the welcoming by starting with the theme paper that I will present it myself. It's a work co-authored with my colleague Adrián Morales, and to some extent it's a continuation of the talk I presented yesterday. So I'm bringing cases outside Europe to reinforce one of the main leitmotifs that I presented yesterday, which is basically that we are not so different. We face the same problems when trying to make the proper decisions, regardless where in the world we are based or our organization. So I'm going to give you a number of examples, and I will commit myself to the 10 minutes that I'm going to ask to everyone else. So whenever I'm more than 10 minutes, please, the co-chair, be tough on me. So as I mentioned yesterday, my affiliations are Polytechnical University in Valencia and IPRESAS, which is a spin-off company devoted to risk analysis on dam structures and other structures. But I'm also currently the chairman of the Spanish National Committee on Large Dams. As I also mentioned yesterday, and it can't be any other way, I live 60 kilometers away from where this dam failed in 1982, and my entire career has been bounded by the fact that during 30 years, Spain made a journey from understanding the safety to dam safety standards to risk-informed decision-making. And at the beginning, I was too young, but I was fortunate enough to do my professional development together with this country-level achievement. Having said that, I presented some cases basically in Europe yesterday. I will present more today. I will start a case I started yesterday, but I will reinforce other aspects so you can get a broader picture of the case in Eastern Europe. I will then move to South America, to Honduras, and we will see other parts of the reality many owners and authorities face. Then I will stay in South America with a case in Argentina to finish with Brazil and India. I will be trying to highlight things that if you put that together with my talk of yesterday hopefully will make a lot of sense. So starting with Albania, as I mentioned yesterday, it's a very critical infrastructure in terms of vulnerability and potential flooding. But what I didn't mention yesterday, which is a very unique thing, it's the dams are physically over-designed. They were built in the 70s by Chinese experts, and they are geometrically over-designed. Did it guarantee a safe operation? No. Does it give you extra margin of safety in some senses? Could be. But in reality, you see the graph I put yesterday. In the y-axis, you have annual probability of failure. In the x, you have potential loss of life. Regardless, geometrically, they are totally over-designed. So theoretically, factors of safety, etc., are very high. The risk is very high. So one thing to demystify is over-design doesn't mean dam safety. Dam safety is a much broader thing. As I mentioned yesterday, there are things that could be done already, like emergency action planning, improving operation, etc. And there are other things with regard to spillways, etc., that will have to wait a little bit to get better data and better understanding. But altogether, it makes a consistent way to move. So what risk brought to this case is a roadmap, is a common consensus on how to do the journey to a less risky situation. Let's move to another case. This is South America, this is Honduras, and this is the center of Tegucigalpa. So the local authorities were trying to improve flood management in the city, but without a systemic view. And what happens in the city, I mentioned yesterday that sometimes the elephant in the room is urban planning. So they have two dams that are for water supply that used to be far away from the city center and have been literally surrounded by people. I can't show it in the picture, but in Los Laureles Dam, there's people living directly in front of the spillway. So how do you manage this situation in which you need the dams for providing drinking water, but you need to ensure the safety of the dam? So risk here brought something which is also unique, is a balancing understanding between the benefits of supplying drinkable water and the need to perform or to do a proper flood protection. So that whole picture is very difficult to get without a risk-informed approach. More examples. This is Argentina. This is a very complex system in Patagonia. It's 4 dams. It's a system with a lateral reservoir that serves for flood protection and many other issues. So the message here, and I think I delivered it a little bit last year also, is they had been thinking on what's the proper thing to do for decades. And there was this overwhelming scenario that the system is too complex. But when we put together, it was maybe Louis, I don't know if you've been ever in a failure mode session with 50 persons. That was our record. So we put in the room, I think it was 52, 53 persons. And there were people from the construction 30-something years ago till young consultants. And we end up with an architecture of a risk model that allowed us first time to see first where we are. Are we above where we want to be? And yes, they were. The second is, if you do different repairs what's going to happen. And it is implicit there, but it wasn't part of the scope at the beginning. There is a planning of building a new dam upstream for other purposes. So we had a conversation yesterday. We said it's not only that you should use risk in the design, but in the planning. So by understanding the risk in the system before the design of that new dam, you can achieve a better systemic solution in dimensioning the upstream dam, which basically is for energy production, but making sense with the overall flood protection in the basin. So we incorporated that. You see one dot there on the new dam upstream, and it's been used in the planning phase of this design. More cases, Brazil. We've been working on qualitative indexes to screen a portfolio of over 160 dams. My colleague Adrian himself did the inspections of 60 of the dams, and we ended up with something that I call the ignition point, which is have all the information together. This is far from being a big system, but it's a first step. You have all the information together, and you have at least a relative sense of where is the risk in the system. It's not perfect. It has limitations. It's an index. It's done, let's say, with an effort of 2-3 days per dam. But remember, when you are changing a paradigm, you need to start. Sometimes, for these large portfolio approaches, screen information being stored consistently, plus screening is the ignition point. So, last but not least, my last 30 seconds, and I'm going to fit to 10 minutes, I couldn't avoid to mention the example of India from the point of view of the guidelines and the work done in Bhadra Dam, who informs one of the appendixes. So I saw part of this graph yesterday, and that's the pillars of dam safety, and failure mode identification could be here, the ignition point. So the very complicated graph to your left, I'm not going to go through it, but I'm going to let you know what it means in 30 seconds. It means that you have to balance different types of information. It means that if you have a very good hydrological information and you have captured well the hydrological risk, why not to go all the way to a quantitative risk analysis and have that insight for your decision? And if you need to prioritize what instruments to install, or what other data to gather, or what other studies to do, you can go through another queue and balance. You can do, if you allow me to say, it's not a dam-centric risk analysis, it's a failure mode-centric risk analysis. So you combine different speeds of analysis, diagnosis, and decisions. So if you are curious, I encourage you to download the guidelines, because the work we did together with the Altares in Bhadra Dam, we created a case which has been incorporated in the appendix of the guidelines, and you will see what's the starting point, how different investments would reduce risk, what's the risk reduction path, the accountability we mentioned yesterday, and this is going to be my last sentence. I really encourage you to download the Indian CWC risk guidelines. Thank you very much, and welcome to the session.
Thank you, Dr. Ignacia Escudero-Bueno, our chairman of this session, for your opening remarks as well as presenting the theme paper. Now I would request our next speaker to kindly come on the dais, Dr. Martin Wieland from Pori Switzerland Limited, Zurich, and the topic is Limitations of Risk and Probabilistic Safety Analysis for Large Storage Dams.
we'll give you 12 minutes. So when you see the 10 there, then you have to go to conclusions.
Okay, good morning, ladies and gentlemen. I would like to talk about limitations of risk and probabilistic safety analysis for large dams. Okay, first, if you talk about risk, we have, it was already mentioned a couple of times, we have an advanced safety concept for dams with a large damage potential, which please have a look once more. Structural safety, dam safety monitoring, operational safety, emergency planning. And for that, there are different methods of analysis. Some are discrete analysis. Also, risk analysis is one method of analysis to be addressed for addressing certain aspects of that. And I would like to just discuss, let me say, the limitations from a point of view of let me say, the hazards on one side and the other side on the vulnerability. Okay, if we look into the hazards, we have hazards from a natural environment, and up to now, basically, all of the presentations have focused on that, on flood hazard, on seismic hazard, we have some geological hazard, and so on. Secondly, we have man-made hazards, we have project-specific hazards, and we have also site-specific hazards. So I would like just to go very quickly through those. We have a big spectrum with a picture from Myanmar which shows just a dam which has been completed. This is a free flow spillway. We have a lot of floating debris which actually blocked the spillway after a heavy rainfall, and the new dam was almost overtopped. You know, it was due to blockage, due to the huge amount of floating debris. Okay. Now, the emphasis I would like to put here is on the man-made hazards, because this is the most difficult part. Okay. If we look at man-made hazard, this is from Ethiopia. You know, for the flood hazard, you use a so-called N-1 route. Here is a big dam outside of Addis Ababa. It is actually N-3. From 5 openings, 3 were out of operation because of lack of maintenance and also already initial design. There were only 2 in operation. Okay, we have the other with, which is mentioned, lack of maintenance, corrosion protection, and vegetation. We have what is also mentioned, this is a poor concrete, high water cement ratio, so we have leakage. Due to the leak, we have a high pore pressure in the dam, which affects the stability of the dam here, especially the stability of the upper part, which hardly anybody analyzes under seismic action. Okay, this is one of the biggest dams in the world. Is in Turkey, is the Atatürk Dam. It had to be built very quickly. It's 170 meters high, and you see just after the inauguration, the top 15 meters had to be removed completely because the settlements were several meters, because it was poorly constructed. It is a man-made effect. Okay, here it was the world's highest arch dam, which is Inguri Dam in Georgia, which actually was just finished a few years before the independence, but in a civil unrest following independence, actually the dam was looted. It was looted, all monitoring system was removed, pumps were removed for draining galleries and so on. So therefore, within a short period, also this dam has probably been designed for 100 years. After 10 years, it was considered unsafe, or nobody knew about the safety, because it was a looting which has taken place in the world's highest arch dam. You know, this is a picture of one of 2 dams which have been destroyed during World War II by a 2.5-ton bomb. You know, you created a big breach in this masonry dam. Okay. Now, this is just to talk about a few words about man-made hazards, which are the most difficult to handle. Okay, now let me say something briefly about risk analysis. Okay, we know risk, and talking about quantitative risk analysis, I must say, okay, because you have here different people speaking about risk, but I'm talking here about quantitative analysis. Okay, in a quantitative analysis, we can say the risk is probability of dam failure multiplied by the consequences, which is basically the downstream flooding, which is a critical one. And since I'm coming from a seismic part, I would like to say a few words about seismic effects. So the failure probability is, in a seismic context, is represented by so-called fragility curves. You know, with the whole nuclear safety, for example, seismic safety is based on fragility curves. So this is a concept which is widely used. So what's given here is, for example, the probability of failure as a function of one seismic parameter, just a single parameter. Okay, this today we would say from my committee, I'm also chairman of a seismic committee of ICOL, we would say this is obsolete. You know, this is old-fashioned. This is not up to date. But I would like to explain here briefly. If you have overtopping, we have a failure of embankment dam, which was already said. We had seismic failure of a dam during the earthquake in Japan in 2011, which was caused due to deformations followed by overtopping, rapid drawdown, secondary failure. Okay, that's the kind of a failure mode. And let me say, okay, I have given a quick overview on the type of hazards, and I have a focus on the man-made hazards. Now let me say something about vulnerability, and I would like to talk about seismic vulnerability, because that is my specialty. But for all the different hazards which I've mentioned, there are different kinds of failure modes. Okay, where different vulnerabilities have to be considered. So let me look in the seismic vulnerability, because I'm often asked, is a dam safe? This is the case of Albania, was already mentioned by Mr. Escudar. This was a small earthquake, magnitude 4.1 in 2009, and you see a peak ground acceleration of 0.07 basically caused failure of this embankment dam. Okay, this is another view here of this dam. The other example I would like to give is the Aratasova dam in Japan. It's a 74-meter high dam, and this dam experienced an earthquake of 1G. It's 14 times more than the case I have shown from Albania. What has occurred in that dam? Basically, this dam has settled 40 centimeters. You can say nothing has happened. This dam has been absolutely safe. Okay, the other dam has actually already failed. What can we learn if we look now in these vulnerability curves? It is extremely difficult, you know, to define the probability of failure, and I must say, from a seismic point of view, this is only one of the different hazards which have to be considered. It is not possible, basically, to define the seismic probability of failure of a dam. It is extremely difficult, and as you have seen from these two examples, there is extremely wide scattering between a well-built dam and a poorly built dam. I would say the ultimate criterion for a dam is the dam built well by the contractor? That is what counts ultimately. Okay. So let me say quickly, to come to an end, what is the consequences of a dam failure? This is from a Second World War, what I have shown from a breach of a masonry dam in Germany. It gives a big catastrophe, of course, in a downstream area with all kinds of catastrophes. This is a picture from Vaillant Dam, where a mass movement went into the reservoir and created a big impulse wave overtopping the dam by more than 90 meters and creating this catastrophe in a downstream area. Okay, let me come to the conclusions here. Okay, the important point, please keep in mind, dam safety, in order to be credible for dams, an integral dam safety concept has to be used, which includes structural safety, dam safety, monitoring, operational safety, and where maintenance is a main issue, emergency planning. Okay, all four factors are equally important, and as I've mentioned, to check, to verify these different aspects, different types of analysis can be carried out. And in order to do an analysis, usually you need design criteria. Otherwise, for people doing a numerical analysis, we will not be able to do. Now, risk analysis, we can say, due to the different nature of many hazards affecting large structures, large storage dams, and the fact that each dam project is actually a prototype application, I would say comprehensive application of risk analysis, of quantitative risk analysis, has severe limitations, and the most severe limitations are with a man-made hazard. So, and the worst man-made hazard, I would also like to say, is sabotage, it is terrorism, it is act of wars. You know, please keep that in mind. These are the most difficult ones. Risk analysis has been used successfully for many hazards. For floods, I would say, is a very good application. But for seismic hazard, it becomes already quite difficult because the seismic hazard is a multi-hazard, and we only know about ground shaking. If we have to consider fault movements, nobody knows the behavior really, what happens to a concrete dam if we have a fault movement in the foundation. Okay, so thank you very much.
Thank you. Thank you, Martin. I'm inviting Louis Haddin to the podium. You want to announce him, or I can do it? So, Louis, welcome. Thank you for coming all the way from South Africa. We're willing to listen to you.
Thank you, Mr. Chi, and good day, everybody. We just wait for the...
Okay. We are not counting the time, but you can start.
While we're busy waiting for my presentation, maybe I can just give some background on myself. I actually grew up, since I started working, I've been working in a risk-informed decision-making environment. I have not grown up in a standard-based working environment. So I'm going to share with you guys today my experience. It's interesting to have seen Martin's take on that you can't use, or in quantitative risk analysis, that you can't look at man-made hazards. But if you use a qualitative system that, like this yesterday post, it's the only system that you can actually use that will give you an idea actually of what you're working with. So that's what I'm going to present for you on here. So if I can go to my first slide, the question that I want to pose to you guys is, how safe is your spillway? And I will talk on the next slide on sort of the normal thing, but also hopefully after my presentation you will be able to actually get a better feel for why do we need risk-informed decision making, especially with something like spillways. And why I say that, if one looks at the standard-based design methods, and if you work especially with the gated spillway, gated spillways will always be more economically than ungated spillway, because you save material. If you work, for instance, with a earthfall embankment, your crest level, you can decrease your crest level. And that is especially important if you're in the planning process. All right. In South Africa, for instance, and other parts of Africa, in most cases, people don't use risk-informed decision-making from the planning process. It's normally a thing that people only start using once a structure is actually in operation. So one of the questions that one actually has to try and answer is the risk of failure. If you design your spillway, do you consider it one gate to fail, 2 gates, all the gates? What do you design for? I don't know. I don't know what you guys, for instance, here do in India, what your design criteria is if you use standard-based. Then the other thing is, do you take into account actually your power source redundancy and the location thereof? I always get the question in Africa, for instance, people ask me, how many people do we actually need? How many operational personnel do we need at the dam? That's really one of the questions that I get asked many times. And you find it very difficult to quantify that if you use a standard-based approach. The other thing, what's the impact of centralized decision-making? And then the other important thing is life cycle cost. In South Africa, we've seen, if over the long term, that the life cycle cost of actually operation and maintenance, in many cases, especially with gated spillways, are more than your initial capital cost. And that's normally not taken into consideration when you do the planning and operation, especially if you use a standard-based method. Okay. So I'm going to, with 2 examples, there's another example in my paper. I'm going to use 2 examples, and hopefully after I've gone through the 2 examples, you guys can see the advantage of actually using a risk-based approach. So this is Hardap Dam in Namibia. It's a asphalt-faced rockfall dam in the south of Namibia. And I will talk about the flood event that happened in 2006. It's a gated spillway, as you guys can see. All right. It actually has 3 power sources to drive the gated spillway. So you have the national grid, there's a standby generator, and they have a small mobile generator operator that you can also use to operate the gates. That's pretty unique in the African environment. Most of the spillway gates, the gated dams in Africa, in most cases, they only have a national grid, in many cases. At most, you might have just a standby generator. They actually do a very good job at this particular dam in that they test all the gates twice a year. So they have a very good system to actually see that the gates are working properly. So what happened in 2006? There was a flood with a peak of about 4,000, and you guys can see it was not even the biggest flood peak that has happened during the history of this particular dam. And this is a consequence of the flood event that happened. It flooded the major town downstream of the dam. But as luck would have wanted it to happen for that particular flood event, the national grid got knocked out. Okay. And these guys test their standby generator really regularly. They're vigilant with the testing of all the systems. But at that specific night when the peak was experienced, the standby generator also failed. So if they did not have a small mobile generator, the dam would have failed. If they only had a national grid, the dam would have failed. If you go and do the back analysis, we would have had a failure. All right. So even with all the sort of the backups and the plans, at least the third redundancy that they actually had saved them in this case. So if one just goes in and looks from a risk point of view, this is a risk system that we use in South Africa. Don't get too worked up about it. The principle that I want to just show you guys is the principle of risk-informed decision-making. But you can actually see on the left-hand side is a consideration of a gated spillway, and basically why the risk impact is shown as a larger block there is that we had to consider it that the gates will not work. So if in my world, if we look actually from a risk-informed decision-making point of view, we always consider it that none of the gates are working. That's the boundary. All right. So our actual risk is there somewhere in between. I see many times, and I'm not critical, but I see many times people do risk analysis. They have a single small dot, but you have uncertainties because you can't, all those aspects that I was talking in the beginning, you don't actually have an answer to that. So following this methodology at least gives you the boundaries of your risk. If I can quickly talk about Bospoort Dam, it's another example. This was a dam pre-2009. I visited this dam for a dam safety evaluation in 2004. You guys can see this photo was taken in 2006. It's a gated spillway, and when we arrived in 2004, this was what you could see, and you could see actually there's some spillage, but there was no rain. So when we actually went onto the crest of the dam, the water was spilling over the spillway gates. So what actually happened there is the dam owner is the biggest dam owner in South Africa. The decision makers decided there that you don't need a person stationed permanently at this dam anymore. So the dam operator is stationed 40 kilometers away. There's no warning system or anything to actually tell the operator what the water level is in the dam. So when we actually asked the operator to open the gates, he informed us that the power supply cables were stolen. So fortunately, he also had the backup system. And when he tried to start using the backup system, of the 12 gates, 5 of them, the cable, you see the pull cable was completely corroded because in the admin officer of this area decided to replace the stainless steel cables with mild steel cables. All right. So if one actually goes and look at the risk of this particular situation, you guys can basically see the risk is off the charts. If one goes and looks actually at the risk under normal operating conditions, that is, so it was still unacceptable if you take into account the human factors and everything that we actually see at this particular dam. And subsequently, the dam was actually rehabilitated, replacing the gates with an uncontrolled spillway, because in many developing countries, as I say, the risks are not taken into account, and the proper provision is not made for long-term proper operation and maintenance. And if one actually now go and look at the risk of the rehabilitation, we have an acceptable risk for this particular dam. So let's just quickly look at the concluding remarks. As I said, from what I've seen, generally, a gated spillway's risk of failure, if you take everything into account, is much higher than an ungated one. I've not seen the opposite. Okay. And to actually lower the higher risk of a gated spillway, it's normally you will have to have some other auxiliary spillway, uncontrolled auxiliary spillway. We normally use the upper boundary. None of the gates are functioning. I've just shared with you guys 2 examples. I have numerous examples in my world where none of the gates actually work that they were able to actually operate them in a flood condition. You also need to consider, when you actually do planning, the redundancy of your power sources and where it's located as well. We've had it where people have sort of a backup generator. They put it away from the dam wall with a power line going through trees. You get a storm event and you lose the backup power supply as well. Then operational personnel. It is very important to make sure that your operational personnel is well trained, but it actually poses a risk. As soon as you bring in a human factor, you increase the risk of actually your failure. While I put the acknowledgements on there, particular Peter Nightingale and the late Dr. Chris Oosthuizen and Andre Moster from NAM Water, I just want another comment that I just want to make. The whole concept with regards to dam safety management. And I've heard some comments in the previous session that I attended this morning, where it was said that consideration should be given for dam safety to take place during the design process as well. Dam safety is not a little tick box that you need to tick. Dam safety is actually the concept where within everything that you design, planning, operation, whatever actually takes place. So I just wanted to make that, for me, for you guys, very clear. It's not a tick box. It is really the sort of the encompassing thing that everything takes place: planning, design, operation, maintenance, decommissioning. Thank you.
So thank you very much, Louis. We're welcoming to the podium to Dr. Jonathan Quiberman. Please introduce yourself at the very beginning.
Okay, good morning. Dr. Jonathan Quiberman with RTI International. We're a nonprofit research institute based in the United States. Today, there's some great lead-up presentations, and I'm actually going to kind of change maybe a little bit of my theming here to talk about the human element, because it's very important, and how some of that is being addressed from the TVA system. Where's the clicker? Thank you. So TVA is a large watershed. It's over 106,000 square kilometers in the United States. Has over 40 actively managed dams, 3 nuclear stations, and a number of thermal facilities. All the dams were built between 1910 and 1978. In 2009, TVA implemented a risk-informed decision-making process, and this was a combination of formal and informal decision-making and review of their projects, PFMAs. So they have potential failure mode analysis for each one of the dams, between 20 to 50 potential failure modes that they'd evaluate, move through the SQRA process. And the highest risks, the highest identified risks, would be moved on to the QRA process. A core theme and important message here is that this process, this RIDM process that they've gone through, is actively informing their capital investments so that they can minimize the risk investment. And so this is an active part of their decision-making process. So very briefly, we can look at the components of the risk analysis. It includes the hazards, the system responses or the fragility curves, the exposure, night-day responses for potential consequences, and then the consequences themselves for life loss or economic damages. What I want to focus on are the hazards. I want to focus on the probabilistic approaches that are used by TVA to assess and quantify the hazards. And so the hazards analysis, we're looking at here an example of a head pond hazards curves. This is the annual exceedance probability of some given head pond level. And we're quantifying these events, and it goes out to 10e-7, which is crazy. That's not something we've observed in the historical record. So you can run your period of record, and you can say, how high did it get? And you could fit some curves to that, but that's not enough. You can't extrapolate out to 10e-7 on the probabilities here. And so TVA has implemented the stochastic event flood modeling procedure. And that's what we're going to be talking about, is the development of the system that's used for stochastic sampling. It uses the law of total probability, and so it allows efficient sampling. So it's a Monte Carlo sampling, and it's efficient that we can sample extreme precipitation events using the law of total probability. And the SCFM process is all about linking these models. It's a workflow of developing storms, synthetic storms, about running the hydrology, running the hydraulics, running the operations models. And the operations models is a very important component because that's where you can include gate failures, and you can include factors such as, are humans able to even get to the dam? Is there a human stationed at the dam to operate the gates or not? And then if they are not at the dam, what's the probability that they can actually get to the dam to operate the gates? So the stochastic simulation runs tens of thousands to even hundreds of thousands of simulations through the system. And so it's a very computationally intensive process. Moving through this fairly quickly here, I just want to highlight some of the unique things that TVA has done for the development of this probabilistic hazards assessment, which includes storm typing. So if we look at precipitation frequency analysis, rather than saying this is the total precipitation and this is the return period, they actually break it out by storm type. So they have 3 different storm types. They have mesoscale of embedded convection, which is a thunderstorm. We have mid-latitude cyclones and tropical storm remnants. So they actually do frequency analysis based on the type of the storm, which includes seasonality. The probability of that storm is not the same throughout the year, and that's very important. And so you can sample across different points of time. There's a number of templates. The storm templates themselves are sampled from, and so we can generate different types of storms, different locations of the storms, and move them through the system using a frequency domain transposition, which is different than just picking up a storm and moving it and adjusting the mean based on DAD tables. You actually move it within frequency domain, which helps with orographic effects. It's a unique approach. And all of this is done to develop the aerial reduction and the 48-hour precip annual exceedance probabilities. So once we have those total probabilities, there's an interesting process of the stochastic sampling where we actually take and generate these extreme events and insert them into the historical record. The precipitation you receive today is going to cause a peak flow next week or in 2 weeks. And we have to say the rain will continue. There was an event, but weather continues, rain continues. And so we actually put that into, we can see the insertion of an extreme event. And we know when to insert it within the random sampling by looking at the process or the frequency of that type of storm, which we can see in the step number 4. This is, the sampling is done also with this long-term series that we can pick any date and time and we can insert this extreme precipitation event into it. Now, this is a very important point because a 100-year precipitation event does not equal a 100-year storm event or 100-year stream flow. Right? It all depends on the initial conditions of the system. If your soil is extremely wet, a 100-year precipitation could develop a 200-year runoff event. Or if your reservoirs are dry, they're empty, the soils are dry, a 100-year precipitation event could be a 50-year event. So this is a very important distinction in why we run a long-term sequence of running that through the system. The flows are routed using variable leg K, which is a very efficient stream routing system. Another interesting aspect of the TVA model is that it uses sloped storage. If we remember, we're doing hundreds of thousands of simulations, and doing sloped storage in a reservoir using something like HEC-RAS or a mic tool is not computationally efficient. The sloped storage is a way to overcome that. All of this is controlled within a riverware system. So we are continually calling riverware tens of hundreds of thousands of times to develop these hazards curves. And this is where you can include the operational effects. You can include gate failures. You can include whether people were able to get to the system or not. You can include blockages of spillways and look at the probability of those events and how that event is affecting the hazard itself. We also built a dashboard to surf all these simulations. 10,000 simulations is a lot. And so this system is to look at the data and visualize the data. We're actually looking at 10,000 simulations here, and you're able to pivot. You can pivot based on your reservoir stage. You can pivot on your peak discharge, peak inflow, other dams. You can look at the information. You can then display it on color, and you can also change the size, which allows the end user, to explore all the simulations to see why is the system responding in a certain way? What conditions are causing high peak water levels? And you can click on any one of those points, view the simulation results, and actually then open up the model itself. And so it's a very useful system for TVA to help explore the system itself. All of that information, after you run all the samples through, you can develop your exceedance probability curves. In this case, we're looking at the head pond exceedance level for one of the dams, and that brings it out to, in this case, 10e minus 6, so a very extreme condition. Another interesting aspect is sometimes when we're managing risk or dealing with risk, there could be structural interventions. It could be spillway modifications, could be gate modifications, etc., or it could be non-structural through the operational side. So this is a quick comparison of two different operating rule curves. And so running the system using the Riverware operations model, we can see what is the impact to the risk, to the hazard itself. And we can see that there is a significant change. The top curve is the headwater annual exceedance probability, and the lower curve is the downstream flow. And we can see how we're able to impact the probability of some hazard based on two different operations conditions. And this was actually used actively by TVA in an emergency situation to make decisions. An important thing also is characterizing uncertainty. We're looking at a probabilistic approach, but there's two types of uncertainty. We have the uncertainty of the parameters themselves, the unknowns within the system, just from random variability, and then unknown because of the parameters itself. And so we can sample through those and develop uncertainty bands around the exceedance levels. So I want to close and just say that we've talked about the gate reliability and blockage. Those are extremely important things that can be included in here for quantifying the risk. It's not all just hydrologic hazards. That is a part of it. That's an important part of it. But it's also the human component. It's also the structural failures. It's the gate not operating. It's the spillway blockage. And that can be included within the system to probabilistically estimate the hazard itself. I also added breaches under the stochastic failures. Is looking at the system itself. It's not just the dam, but it's other dams. This is a system of dams. So how are other failures affecting the probability? This is also not a static study that we did. This is deployed at TVA. So TVA has this in their system, and they're actively using it. And it's not overly conservative. If you're making capital investments, you don't plan for the PMF. Look at what's really your best estimate of what really is on the hazard. And so this is not an overly conservative. We have the uncertainty around it, but it's really the best estimate of the approach. It's a pioneering system. The way that the SCFM was implemented within TVA, the linking of the models, is a very powerful system. And so just to close here, I'd like to acknowledge Tennessee Valley Authority for their support in this and their generous willingness to share this information with you all today. So thank you very much.
Thank you very much, Jonathan. So last, Mr. Elmar, please don't forget to introduce yourself and don't forget to introduce yourself and let us know a little bit about you.
Good morning, ladies and gentlemen. It's a great pleasure for me to be here and to present you in the next few minutes a risk-based maintenance methodology that we developed together with our partners in Switzerland, with Alpic, which is a big producer in Switzerland with a market share of around 40%, and with Oxand, which is a company specialized on risk management. I myself, I'm presenting hydro exploitation. Hydro exploitation is a service provider. We provide, I have to switch on, We provide services to the owners of hydropower plants, and we are running and operating around 46 hydropower plants in the southern part of Switzerland with an installed capacity of around 3,000 megawatt and a yearly production of 5,500 gigawatt hours. We are not the owners of these assets, we are just maintaining and operating these assets on behalf of the owners. We are doing this with around 430 people, mainly people on site, specialists on operation and maintenance, also with an engineering department, and also with other people, administrative people. Until 2013, it went very well for the producers in Switzerland. They could sell their electrical energy for 8 cents per kilowatt hour, and they had around production costs from around 5 cents per kilowatt hour. So they had a very nice margin of around 30 to 40%. That allowed them to make a very good maintenance, perhaps a too good maintenance, also preventive maintenance. And then suddenly, beginning of 2013, the market price of the electrical energy dropped very fast to around 3 cents per kilowatt hour. That meant that they lost, each kilowatt hour they sold, they lost 2 cents per kilowatt hour. So what are companies normally doing when they lose money? They start cost cutting. But cost cutting in this situation has to be done in a very intelligent way, because in the production costs of around 5 cents per kilowatt hour, 75% of the costs are fixed costs. These are capital costs and taxes. Only 25% of the cost could be influenced, because these were variable costs, mainly operation and maintenance costs. So you see on the next picture, you see a little bit, you can do not enough maintenance, but you can do also too much maintenance. When you are doing too much maintenance, you have high maintenance costs, you have also a lot of shutdown times, and you lose availability, and you have higher costs. You can also do not enough costs, not enough maintenance, which costs you also, because you have to repair, you have cost of repair, you have also cost of non-availability. In this case, we estimated the cost-saving potential to between 15 and 20% of the initial cost of the actual cost. So this meant in our specific case around 10 million Swiss francs per year. Now we developed together with the owner, with LPIC, a methodology with which one we wanted to adapt the maintenance plan of each hydropower plant to his needs, also to the financial possibilities of the owner, and also to the strategic importance of the maintenance plant. For small maintenance plants, when they when they have a shutdown, it's not so important, because they do not contribute to the regulation of the grid. For the big hydropower plants, it's more important that they have a high availability, and so you cannot treat every hydropower plant the same way regarding the maintenance plans. We wanted to offer somehow basic services for everybody, and then discuss on a risk-based approach what has to be done in addition to this basic service. And this was very important also to get from the owner the information, what is his targeted performance, what is the availability he wants to have. Wants he to have availability of 80%, 90%, 50%. And depending on this, we could also make the approach. We started with a health status of each hydropower plant, and then we made the risk analysis based on the experience we had over this regarding this hydropower plant. And we then optimized the maintenance plan, and we developed together with the owner the maintenance plan for the future. And this maintenance plan was lower. Normally there was less work to do with this maintenance plan than it has to be done before. And so we treated every hydropower plant in a different way. And then we implemented this maintenance plan, and we measured certain KPIs, key performance indicators, which showed us if we are on the right way. Are we with our KPIs? Do our KPIs are according the KPIs that we have discussed with the owner before we made this work? For the health status, we applied a methodology, a very simple methodology, a standardized methodology where we rated we devised the whole hydropower plant from the intake to the transformer where we deliver the electricity to the grid. We devised it in 33 elementary systems, and we judged every elementary system between 1 and 10. We judged it based on the experience. We made the historical data. We judged it based on the age, on the cycles. We judged it on the inspections and also on measurements that we have done on these installations and on these equipments. It was easier for us because we are maintaining and operating these hydropower plants, this equipment, so we had already a lot of knowledge from before. We had information from the control system. We had information from inspections. We had information from measurement we were making in the former time, and so we could.
No. The thing is that it started very late. I wanted to tell you.
Okay.
So
I will.
So you were 10 already.
Okay.
If you can.
Swiss people are known to speak very slow. I try to speak now very fast.
I wanted to say that it had started quite late. So please
I try to consolidate the thing, and then so we could, for every equipment, rate somehow a health status between 1 and 10. You see here the health statuses of the different equipments. With this one, we then made the calculations, risk analysis, based also on probability of failure curve, which we based on literature, on experiences, and on operating conditions. Then we saw we could propose to the owner where he has to invest his money, which was not as much as before this drop of the prices, where he can invest the best his money, and has he to change, for example, a transformer this year, or he has to change a transformer in 3 years, and what are the risks if he changes the transformer in 3 years, and what are the maintenance, what are the controls they have to be done if he wants to move the change of an equipment, for example, for 2 years. This gave then this optimization where we could tell them where they have to invest the best their money, and then we are monitoring this now. We implemented these maintenance plans. We are monitoring this now, and we are measuring if what we expected to find with our analysis, it's also conform. It's also according the KPIs that we defined together with the owner. I come to my end. What are key success factors of this approach? The key success factors are really to involve the people on site. You have a lot of people on site. They know their installations. These are their babies, and they know what are the difficulties, what are the weaknesses of their babies. You have to involve them. You have to consolidate all this know-how coming from the owners, coming from the people on site, coming from the maintenance engineers. We have to exchange also, since we are running around 46 hydropower plants. It was also an advantage for us that we could exchange between one and the other hydropower plant, and to see what are the experience that they made in another hydropower plant, and where we could profit of this experience. And last but not least, we have to manage all the competencies also in the future. We have to manage them and to bring them all together. I close my presentation with the highest concrete gravity dam in the world. It's Grand Ixas. It's a 285-meter high gravity dam. We can operate and maintain this gravity dam, and the owner is Grand Ixas. We are just the service provider to do this work. Thank you very much for your attention.
So thank you very much to all the speakers. Though we have been told to be very severe with the timing, I think we made a good job. We'll have to close in 10 minutes. We need 5 minutes for the closing remarks and the presents. So we'll take questions during 5 minutes. To some extent, I'd like, if possible, to arise questions that might be based in the Indian context. I don't know what could be the most important theme, because we have talked about a very diverse variety. I'm thinking the gates, I'm thinking the investment in maintenance. So I open the discussion. Please feel free to ask to whoever you think that can address your question better. So there's no question there? So I don't like when there's no questions. I have on the left, where? Okay, go ahead, please. Please say who you are, gentlemen.
Good afternoon, I am R. Balamurugan from Center for Water Resources. This is a very risky time to ask questions. Anyway, as academic persons, we are doing modeling. For here, risk is for a dam or the people downstream of it. So we need to look at both together as risk management. Okay, that means the dam should be also in a safe condition. At the same time, when you left out in the damaged condition in the downstream side. Therefore, I want to ask I think all of them are doing in the risk assessment in a good manner. For anyone can answer for how to make the risk value, because the reliability is one minus risk. Therefore, how to value this risk in a context of the people perspective or the dam perspective. So that is my question. Quantification.
So, yeah. As you didn't address it to anyone, I'll try to go straight to the point. I think you made a very good point that it's not about the structure, at least not alone. It's about the broader picture. And the significant number, or the significant order of magnitude, or the significant input is about the system, including population, downstream, upstream, or the system. So I think that's a point the panel would agree. And the second, on how do you do it, I have to say that there's now a recently released Indian guideline that could be a starting point for discussion, but I think everyone in the panel will be happy to discuss with you during the lunch, because that's super specific. More questions? Experiences with gates. That's typically a gentleman there. This might be our last question.
Hello. I am H.K. Verma from International Commission on Irrigation Drainage. I like to share failure of one dam in India, which is similar to which was described by Mr. Luis. It is failed because it was raining very heavily, and they were having the generator, but when they started the generator, current was leaking to the platform. They have to close the generator and they lift the gate by handle. And because of poor maintenance, 2 gates they could lift only 1.5 meter, and then dam overtopped and failed. So this gate operation and maintenance is very, very important for avoiding the failure of the dam.
You want to add something, Louis? That's fine. So maybe one final question, or
hello.
Where? There. Okay.
Yes.
This is the closing question.
Yeah, this is Professor Vijay Kumar Dwivedi from National Institute of Technology, Durgapur. You have initiated a very good point the discussion in Indian context. So it can go very fiery, but we don't have time, so let us be limited to the time. And the basic problem is non-operational of the dam appurtenances and the gates. And the basic problem is the financial management at the dam site. And you might recall 2008 Koshi flood was only due to failure of the spillway gates. And at that point of time, no one was being able to sanction only 10,000 rupees for the greasing of the channels for the gates. That is a hilarious situation, and that caused millions of losses, and thereafter simply writing some files and the things are gone. So Dam Safety Conference must think very seriously what should be the guidelines for the financial autonomy of the people who are on the site. If that is solved, most of the dams, and the question which the gentleman raised, people downstream will also be safe enough. That's what I will restrict myself.
Okay, I think
Thank
we are
you.
closing with this, and we are going to the closure ceremony of this session. Before, I will ask our Vice Chair to summarize some overarching key points. Please go ahead.
In the first place, let me thank all the presenters for excellent and very interesting presentations. Let me try to summarize a little bit the discussion. But before doing that, let me also provide a little bit of context. Yesterday we heard that India is going to significantly scale up its investments in dam safety, and the World Bank is ready to support that. The implication is that, in the first place, we will need to go significantly beyond investments in hardware if we are to scale up the investments in dam safety. We will need to work on the institutional framework for operations of dams, construction, and also in particular on the issue of risk assessment, as we discussed during this presentation. That risk assessment, the approach to risk assessment needs to be very systematic, needs to be comprehensive, needs to be an integrated approach other than an ad hoc analysis of the risks. And that risk assessment would consist of a number of issues, and we heard some of that during the presentations. We were talking about risk-informed decision-making. We were talking about semi-quantified risk analysis. We were talking about the PFMA. And so there are a number of approaches, a number of systematic, integrated, comprehensive approaches to risk analysis that we will need to further develop and apply in India. And as far as I'm concerned, we need to incorporate all these systematic approaches into the design of any future engagement in India on the issue of dam safety. The analysis obviously has to be based on principles, but we also have to realize that it has to be case specific. Not two dams are the same, and not two risk profiles of dams are the same, and therefore it calls for very pragmatic and very case specific measures to dam safety analysis. Important is also periodic review, as we heard in one of the presentations. A risk analysis is not just a one-time kind of thing. It has to be periodic, it has to be systematic. Risk can change over time, dams can change over time, and therefore the risk analysis has also to change over time. Risk scenarios, we learned about that. We spoke about the risk scenario associated with gated spillways. I remember that in the discussion on the rehabilitation of Hirakud Dam, we had a lot of discussion, especially on that same topic of gated spillways. So an important issue in identifying the scenarios for risk assessment. We also learned about the scenarios for reliable power supply to dams, including generators and backup generators, and maybe even backup generators. We learned also about staffing, staff capacities, personnel, important issues in addressing the dam safety. And we also learned that dam safety does not only apply to the construction, the design and the construction phase or the operation phase, but very important also to the maintenance phase of dams. Maintenance-based, risk-based maintenance is an important element in the overall approach to the safety of dams. Thank you very much.
Thank you, Mr. Ijsbrand de Jong, for the concluding remarks. Ladies and gentlemen, we thank all of you for your very attentive presence. We thank our session chairman and our session co-chair for conducting this session and saving us a lot of time. Thank you so much. The rapporteur for the recommendation of this session. As a token of our gratitude, we would like to present memento, and for that I would request our session chairman, Dr. Ignacia Ecuador Bayano, to kindly do the honors. I would request him to kindly present our memento to our co-chairman of this session, Mr. Ijsbrand de Jong, the lead water resource specialist from World Bank, India. So you could come forward. We can take good picture from there. Thank you. Request you to kindly give memento to our rapporteur, Dr. Hadous Sagad Hagos. Our speaker, Dr. Martin Wieland. Dr. Martin Wieland from Switzerland. Mr. Louis Harting. Dr. Jonathan Kubman. Mr. Elmar Joseph Kafpin. Thank you, Session Chairman. And now I would request Sri P.K. Jena, Principal Secretary, Water Resources Department, Government of Odisha, to kindly give memento to our Session Chairman. May I also request? Thank you, Sri P.K. Jena. Can I request all the speakers to kindly come on the stage for a group photograph? Ladies and gentlemen, we would be immediately starting the interaction session with the Honorable Minister of State, Sri Arjun Ram Meghwal. He's already here. So this would be an interaction session with him. Kindly remain seated. Thank you, gentlemen. Ladies and gentlemen, with this we conclude the technical session on safety reviews and risk assessment. We thank all of you once again. Before we begin the next session, just a few announcements for all of you. We gave the feedback form to you in the first half of the day. We request all of you to kindly take a few minutes and fill up the feedback form, which is very important for all of us. We would like to know your feedback on the different aspects of the conference. Kindly fill up the feedback form. You can either leave it at the registration desk or to one of the organizers, or you can leave it on your seat as well, and we would have it collected. The lunch for the dignitaries, the session chairman, the session co-chairman, all the speakers have been arranged in the banquet hall in the NX building. So, to take care of the rush which happened yesterday, we have arranged lunch at different venues today. For all of us, the lunch is served in the exhibition hall and there's a different venue for dignitaries, the session chairman, the session co-chairman, and speakers, which is being arranged in the banquet hall in the annex building. There you can also interact with our Honorable Minister of State, Sri Arjun Ram Meghwal. He would also interact more with you during the lunch hour. So we have the privilege of his company during the lunch hour. So he would be interacting with you over there as well. There's also an announcement for all the delegates who are leaving today. So if you have your planned departure today, we would request all of you to kindly share your departure details at the registration desk so that the further arrangements can be made. Once again, for all the delegates who have their scheduled planned departure today, please leave your departure details at the registration desk so that the further arrangements can be made for all of you. May I request all our guests and delegates who have just joined us to kindly take a seat. We would be starting the interaction session with the Honorable Union Minister of State, Sri Arjun Ram Meghwal, very soon. In case you haven't received the feedback form yet, you can ask the feedback form. We distributed it in the morning in the hall, but if you haven't got a copy yet, please let us know.
Sure. Sure. Hello. Hello.
Good afternoon, ladies and gentlemen. We would be starting very shortly. May I request all our guests who have just joined in to kindly come in the forward rows and have a seat. May I request all our guests who are in the rows little behind, could you please come forward and occupy the front rows? Please come forward and occupy the rows in front. Ladies and gentlemen, we are starting the session. I request all of you to kindly keep your mobile phones before we begin and settle down. Our Honorable Minister is here. Can we please welcome him? Please rise and welcome him. Thank you, ladies and gentlemen. This is our special session, the interaction meeting with Shri Arjun Ram Meghwal, the Honorable Union Minister of State for Ministry of Water Resources, River Development and Ganga Rejuvenation, Government of India. Ladies and gentlemen, before we begin, very shortly I would like to share with you that after graduation in law and post-graduation in arts, Shri Arjun Ram Meghwal qualified for the Rajasthan Administrative Services and worked in several capacities before taking voluntary retirement from the Indian Administrative Services to enter politics. He got elected for the Parliament in 2009 and 2014. As Minister of State for Finance, he did remarkable work for successful implementation of goods and service tax. His special interests includes singing, instrumental and vocal, especially spiritual bhajan, morning walk, yoga and pranayam. We are very honored to have, though we would have loved it, we are very honored to have your very esteemed presence, sir. And currently, he is the Union Minister of State in the Ministry of Water Resources, River Development and Ganga Rejuvenation and Parliamentary Affairs in the Government of India. We are very honored to have you, and we would like to present you with a bouquet as an extension of our warm welcome. And I would request Shri U.P. Singh, Secretary, Ministry of Water Resources, River Development and Ganga Rejuvenation, Government of India, to kindly present a bouquet to Shri Arjun Ram Meghwal, the Honorable Union Minister of State. A very warm welcome to you, sir. And thank you, Secretary. And with these words, I also request Shri U.P. Singh to kindly give the welcome remark.
Friends, very good afternoon to all of you. It's our good fortune that our Minister of State for Water Resources, who is also a Minister of State for Parliamentary Affairs in Government of India, is amongst us. It's a very difficult time for the politicians. Elections are around the corner, and so finding time for a conference like this is not very easy, and still Honorable Minister has, even though he was supposed to go to Bikaner, he is just amongst us for a few hours. He will take a flight again in the little late afternoon and go to his place. So first of all, I welcome on behalf of all of us present here, on behalf of the organizers, which is Ministry of Water Resources, River Development and Ganga Rejuvenation, Central Water Commission, Department of Water Resources, Government of Odisha, World Bank, on behalf of all of us here, I extend a very warm welcome to Sri Arjun Ram Meghwal. Sir, I would like to just very briefly tell you, sir, this event we do yearly actually under a DRIP program, which is Dam Rehabilitation and Improvement Project. We do it every year. Last year we met at Trivandrum, and last year only we decided that next meeting would be held in Bhubaneswar, which is, sir, you know, not only at one hand it's a smart city, at the other hand, sir, it's a city of temples. So this is a place where modernity and tradition really meet, kind of. They say East and West do not meet, but whereas Bhubaneswar is a place where East and West really meet, sir. As I had told you, sir, as you are aware, since this is my cadre, this has been my Kam Bhumi for 20 years, so naturally it has been a pleasure coming back here and meeting my old friends, and at the same time participating in this workshop, sir. Sir, we started the day one yesterday. We had an inaugural session where, apart from other dignitaries, Minister for Water Resources from Government of Odisha, Mr. Niranjan Pujari, whom you know very well, sir, he was present here. And we had an inaugural session, then we had a plenary session where Country Director World Bank and President ICOL also spoke, among others. Then we have our technical sessions. In total, 4 technical sessions were held yesterday, sir. 2 parallel sessions, 2 into 2, 4 sessions were held yesterday. Of course, we also had, sir, today in the morning 6 technical sessions actually. And then this is a special session we have organized for you so that the participants can have some interaction with you, or they would be eager to listen to you. We, again in the afternoon, after lunch, we will have 4 technical sessions, 2 parallel sessions, and thereafter we will have a valedictory session, sir. Apart from that, sir, we have exhibition here, where about 40 stalls, different kind of exhibitors are showing their products actually, and the technologies. We have participation for about 30 countries, sir, and total delegates, of course, who are attending is 750, 800 kind of. Sir, dam safety is not something which is new, but this DRIP is bringing out some kind of a culture for dam safety in India. We started, sir, earlier, certain initiatives were there are certain committees, there are state level committees, but as a project or program also we started earlier, sir, something called a Dam Safety Assurance and Rehabilitation Project, DSRP, which was implemented in 4 states between 91-99, and based on the experience of DSRP, sir, we started what is called a Dam Rehabilitation and Improvement Project, which is right now ongoing, and under that program only we are organizing this workshop. This program, sir, started in April 2012. It was a 6-year program, but now it has been extended by 2 years, so it will come to an end in June 2020, sir. 223 dams are being rehabilitated under this project. The 7 states, these dams are located in 7 states, sir. And in addition to rehabilitation of dams, which basically means more kind of stress dams are there. Sir, we have very large number of dams which are old, actually pretty old, and some of them maybe because of not proper operation and maintenance, they could be told to be a distressed dam. So basically a rehabilitation of 223 distressed dams have been taken under this DRIP. Rehabilitation basically means, sir, here it's more kind of an advanced kind of a repair, you can say, sir. Not rehabilitation of the people affected by that, rehabilitation of dams. The cost of, now revised cost is 3,466 crores. Basically it's the states which take a World Bank loan. But apart from, sir, yesterday also I highlighted that apart from rehabilitating these dams, what is more important that we are learning a lot regarding the dam rehabilitation, in the sense that, and operation, how to have a proper operation manual, guidelines, emergency action plan, because generally we would not like that there should be any dam breach or dam breakage. But in case if such a things happen, then how do we minimize the loss to life and property? So emergency action plans, how to study properly the health. For example, sir, today knowing a person's health status, we have all kinds of checkups actually. Somebody does a full body checkup, somebody checks up for blood pressure or whatever, heart problems or whatever. Similarly, we are also basically developing a software. We have developed a software. Now that is also application, that how we properly assess the health of a dam in time so that the remedial measures can be taken. So that is also a part of the project. Very large number of Indian engineers have been trained, because, sir, what is happening that there were very large dams were constructed in 50s and 60s and up to 70s and maybe early 80s or so. Thereafter, there haven't been many big dams being constructed. So today the new engineers who are coming, perhaps they do not have the kind of experience which the earlier people have as far as the dam related matters are concerned. So we need to train them also properly. So that's why we have organized very large number of training programs both in India as well as abroad. We are also have taken up 9 institutions whose capacity building we are taking up. We are equipping them so that tomorrow they are the ones who would help us, and every time we do not need to depend only on the foreign experts. So all this is being discussed, sir. The further discussion will take place. One more thing, sir, we have the Odisha government has been, and led by Pradeep Jena. has organized a very beautiful cultural programs for the last, already we had 2 nights and 12th night also it was organized, where and yesterday also we had a very wonderful program, a kind of a sand artist who has now as a world fame. He showed to all of us how even sands can talk basically. Within seconds he can convert a temple into a mosque and then onto a church or something. So it has been highly appreciated by the delegates who have come from abroad as well as from India. And tonight also it has been programmed as a part of, because I have been exhorting them that since here, this is a very beautiful city. Earlier which was known as Kalinga, it has a very rich history, it has a very rich culture, it has on culture index, maybe on all parameters of economic development, Odisha still may not rank very high, but on cultural index perhaps it would, like when you go to, let's say, a Puri temple and there is a village, Raghurajpur village, before you reach about maybe 8 kilometers before Puri or so, where every household, there is not a single household is not an artist actually. Every household, every person is an artist. The Patachitra, what we call, is a world famous. Odisha has not only a Odissi dance, which is a cultural dance. You also saw the first day Sambalpi, which is more like a folk dance. Not only that, every tribe, Odisha is a house of tribes, which you might have heard of, tribes like Bondas, which at one point of time were called primitive tribes, actually Bondas, Didais, Koyas, all these kinds of fascinating people are there. And they have their own dance forms, and also it may not be possible for all of you to see all of that, but maybe at least the Bhubaneswar, the Konark, Puri, Chilka, they are the least perhaps you could do it. So some programs have been organized for that also, sir. Some of the people are also going to some Hirakud, sir, which is one of the iconic dams, not only of course largest dams in Odisha, but one of the iconic dams of India. So, sir, this is what has happened, and we do hope that deliberations here would be basically fruitful for us. We have also told them about the new legislations which we are going to bring on dam safety, because right now, sir, the institutional framework and the legislative framework for a dam safety is not very robust in India. So with the new dam safety bill which has been introduced in the parliament already, hopefully we will be able to enact that act soon, and that also would be helpful. So with this was more for the information for the minister. I am sorry that some of the things which I have stated here is a repetition from what I have already stated yesterday. So with these words, I once again welcome our Honorable Minister. Thank you very much.
Thank you, Shri U.P. Singh, Secretary, Ministry of Water Resources, River Development and Ganga Rejuvenation, Government of India, for not only a very warm welcome address, but also putting the key points in such precise words about the DRIP program, and highlighting the key points of the International Dam Safety Conference 2019, and also about the soul of incredible India, that is the state of Odisha. Thank you so much. Ladies and gentlemen, we also have the distinguished presence, as you can say, of Shri S. Masood Hussain, Chairman, Central Water Commission. Dr. Isbran Jong, the lead water resource specialist from World Bank, is also there with us. Dr. Michael F. Rogers, President, ICOLD USA. And also Shri P.K. Jana, the Principal Secretary, Odisha Water Resource Department, is also with us. And now I would request our Honorable Minister of State, Shri Arjun Ram Meghwal, to kindly address this august gathering, please.
International Dam Safety Conference 2019. I think it is a very good conference, symposium, or you can say a seminar. As our Secretary U.P. Singh ji told, that it is a learning experience also. I welcome Dr. Michael F. Rogers, President, ICOLD, Secretary Water Resources, UP Singh ji, he is on the dais. Shri Masood Hussain, Chairman CWC, he is also on the dais. Jisbrand Jong, a representative of the World Bank, he is also on the dais. And P.K. Jaina, Principal Secretary, Water Resources Department, Government of Odisha, he is also on the dais. The remaining delegates who are sitting in front of me, I also welcome you all. But I can see the last two people, they are engaging in the mobile. So whether you are seeing something, the dam safety bill or something else. I am told that the 30 countries are participating in the conference. Is it true? 30. And the remainings are the Indian delegation. Can you take the attendance? How many from the Jammu and Kashmir? Yes, yes. Thank you. Please. Punjab? Only two? आज जी शर्मा जी बैठे हैं क्या? नमस्कार, क्या हाल चाल है? बिल्कुल साहब, नमस्कार, आपसे मिलके अच्छा लगा। हरियाणा से भी हैं कोई? हरियाणा? अरे आप बिजी हो क्या मोबाइल में? क्या कर रहे हो आप? इतने बिजी मत रहो। मैं बेसिकली टीचर हूं, तो अगर कोई मोबाइल में बिजी रहेगा तो मैं देख लूंगा भैया, ठीक है ना? देख मतलब पहचान लूंगा भाई ये मोबाइल देख रहे हैं, तो मेरा अटेंशन ये रहेगा कि आप थोड़ा अभी जब बैठे हो यहाँ तो आप कॉन्फ्रेंस में बैठिए। आपके साइट सीन का प्रोग्राम रखा होगा ना? है जैना साहब, रखा है मेरे? हाँ, तो उसके लिए टाइम है। देयर इज ए टाइम फॉर साइट सीइंग, उसके लिए रहिए। अभी 5-10 मिनट के लिए मैं आपका अटेंशन चाहूंगा। आई एम टोल्ड दैट ऑन 12th you hold a NCDF meeting. It's true? In Odisha, in Bhubaneswar itself. किसने भाग लिया इसमें? NCDF में। अच्छा, ओके, गुड। Now I'm coming to, there was a good news yesterday that I think the World Bank has accepted the Government of India proposal of 11,000 crore. It's a good news for me also, and it is a great achievement of the department also. So we will, यहीं से दे दो नितिन गडकरी जी को धन्यवाद, जोर से ताली बजा करके। मैं सम्मिलित हूं और यूपी सिंह जी को भी दे दो। बड़ा प्रोग्राम है ना साहब, ये तो बड़ा प्रोग्राम है, 11,000 करोड़ का वर्ल्ड बैंक एक्सेप्ट कर रहा हो। इट्स ए गुड प्रोग्राम, ए गुड न्यूज। माई मिनिस्ट्री is committed to ensure safety of the dams, to protect life and property, and maximize the economic benefit accruing from the dams. Economic activity. मैं आपके इंटरेक्शन करूंगा। देखिए, इकोनॉमिक फील्ड में डैम ने बहुत बड़ा काम किया। आपको पता है, जब पहला डैम बना तो हमारे यहां जो प्राइम मिनिस्टर थे, उन्होंने उस डैम को क्या नाम दिया था पता है? मॉडर्न टेम्पल ऑफ इंडिया। कागनी का भाखड़ा को। अच्छा, वो टेररिस्ट एक्टिविटी कहां हुई थी जिसमें आपने शर्मा जी पानी थोड़ा कम कर दिया बोला? वो कौन थे, कौन से डैम में थी वो? भाखड़ा ही। और अभी तक उसके वो जो डैम में पानी आता है उसको आप पूरा नहीं कर रहे हो। क्यों? वो कब हुई होगी? क्यों यूपी सिंह जी इसको नहीं कर सकते ठीक क्या? वो चेयरमैन थे क्या जो घूमने गए थे और टेररिस्ट ने गोली मार दी थी? देखिए डैम, हाँ बोलिए शर्मा जी, बोलिए। ये इंटरेक्शन सेशन है मेरा खुद का भाषण नहीं है, इंटरेक्शन सेशन है। हाँ बोलिए।
नमस्कार सर। इनफैक्ट सर, ड्यूरिंग द ईयर 1988,
yes,
there were floods, and the level in Bakra Dam reservoir was such that it rose to 1692 feet elevation.
Yes.
Water started entering into the dam galleries, so the floodgates were opened. That time, the terrorism was at the peak in Punjab.
Peak in Punjab.
And the terrorists, they thought that the water which has been released from the dam is on account of to flush out the terrorists, because they were hiding in certain areas and they were on the river banks which were covered by grass, and most of the terrorists, they got washed away, and in turn then they came to the residence of the chairman, who was my predecessor, General Kumar. They came and shot him. Thank you, sir.
सर अब 88 से वहाँ के लोग कहते हैं, मैं भी जाता हूँ, आपको भी कहा होगा कि टूरिस्ट अट्रैक्शन का एक महत्वपूर्ण सेंटर बन सकता था। एक इंसिडेंट ने ये इतने काम एक साथ रोकी। क्या करता है डैम अगर पब्लिक लाइफ का हिस्सा नहीं होता तो हमने अभी CWC ने एक इन प्रिंसिपल सैंक्शन दी। कौन सा डैम बनाने के लिए? वहां का मेकेडातु। और कितना हल्ला पार्लियामेंट में और कितना हल्ला तमिलनाडु और कर्नाटक में हो रहा है। भाई इट मीन्स डैम इज ए वेरी अट्रैक्टिव ए सेंटर nowadays. If you give any principal sanction of the DPR, some people oppose, some people support. Why? एक जमाना था जब डैम की कोई सैंक्शन डीपीआर भी बन जाती थी तो कोई हिलता ही नहीं था, कोई हल्ला नहीं होता था। इसका मतलब डैम बहुत इंपॉर्टेंट एक आपका एक्टिविटी है। और डीपीआर बन जाती है तो और तरह की कई चीजें आ जाती है। कई एनजीओ आ जाते हैं, नो 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 ये डैम नहीं बनता। पंचवेश्वर तो अभी कुछ नहीं है, एक कंसेप्ट है, तो वहां भी एजिटेशन करने पहुंच गए। पंचवेश्वर से कोई आया क्या? पंचवेश्वर डैम के आसपास से उत्तराखंड से कोई आया? नहीं पहुंचे क्या? वहां पहुंच गए ना हल्ला करने। इसका मतलब कितना इंपॉर्टेंट होता है डैम। If we provide in principle sanction, there is agitation. If we submit DPR, there is agitation. If we construct the dam, again there is agitation. If we complete the dam, then there is agitation. अभी हमारे प्राइम मिनिस्टर साहब ने क्या कहा इन पार्लियामेंट में? सरदार सरोवर डैम फाउंडेशन स्टोन ले किया किसने? पंडित जवाहरलाल नेहरू ने। और लोकार्पण किया नरेंद्र मोदी ने। कितना गैप है जी? कितना बड़ा गैप है? ये प्राइम मिनिस्टर साहब ने अपने एक भाषण में कहा है, अभी सुना है क्या? इतना डिले क्यों होता है? हम सबको सर्च करा उन्होंने। क्या है ये? कौन लोग हैं? जब हम कहते हैं कि डैम से इकोनॉमी बदलती है, डैम से लाइफ चेंज होती है, एक डैम बनता है, इरिगेशन का हेक्टर बदलता है, इरिगेशन फैसिलिटी भी इंक्रीज। अभी डैम अगर सरदार सरोवर नहीं होता तो मेरे राजस्थान में जालोर सिरोही में पानी नहीं आता, वहां के किसान भूखे मर जाते। ये बागड़ा और पोंग नहीं होता तो मेरे डेजर्ट में कोई पानी नहीं आता, ड्रिंकिंग वाटर की प्रॉब्लम हो जाती। कितना बड़ा काम करता है जी डैम। इतनी इकोनॉमी को चेंज कर रहा है डैम, और फिर इसका विरोध, और इतनी मात्रा में विरोध कि सरकारें भी कई बार हेल्पलेस हो जाती है। यह भी एक चिंतन का विषय होना चाहिए। होगा या नहीं होगा आपकी कॉन्फ्रेंस का ये विषय? वेदर इट इज ए सब्जेक्ट फॉर डिस्कशन ऑफ दिस कॉन्फ्रेंस और नॉट, इट शुड बी। बताइए भाई साहब जो पीछे खड़े हैं, इट शुड बी, इट शुड बी द टॉपिक ऑफ द डिस्कशन कि डैम का डीपीआर, कंस्ट्रक्शन, कंप्लीशन, रिहेबिलिटेशन, सेफ्टी, ये सारे एंगल एक साथ देखे जाने चाहिए। मैं शर्मा जी, आपको ध्यान है कि मैं कब आया था आपसे, शायद मिला भी था, आपको ऑफिस आया तो भाखड़ा डैम के आसपास गए तो 3-4 लोग मुझे मिल गए कि साहब हम डिस्प्लेस्ड हुए थे उस समय। अरे मैंने कहा यार कब हुए थे? अब उस समय आप घूम रहे हो यहां कि आपका पता लगा एक मंत्री आए हैं भारत सरकार के, तो वो मिल गए मेरे को। मैंने कहा आप उस समय डिस्प्लेस हुए तो आपको पैसा दे दिया होगा ना? तो एक कागज दिखाया, एक आदमी को दिया 7 रुपए, 7 रुपीज। वो मानेगा क्या कभी? उसकी एक दुकान थी, उसको 7 रुपए दिए और धक्का दे के बाहर कर दिया। ये नहीं हो सकता जी। ये सब चीजें अपने को देखनी पड़ेगी कि क्यों इसका अपोजिशन होता है। क्योंकि वी डोंट हैव ए प्रॉपर रिहेबिलिटेशन प्रोग्राम while constructing the dam. That is the issue. Again there is a ecology issue, environmental issue. We have to keep in mind the environmental and ecology issue also. ये भी कोई छोटा इशू नहीं है, इकोलॉजी और इन्वायरमेंट। We have a 2 issue. One is economy, the other is environment. और ये जो आपकी वर्कशॉप हो रही है, इट्स ए यूनिवर्सिटी, किट यूनिवर्सिटी, अभी मैं देख रहा था, यूनिवर्सिटी का हॉल है। ये हॉल तो बहुत अच्छा, अभी जिसकी भी है, मुझे लगता है स्वागत करने लायक हॉल है। ये ताली बजा के भी स्वागत करना चाहिए। इट्स ए गुड हॉल। और इसमें आप बैठे हैं, 2 दिन आप वर्कशॉप में भाग भी लेंगे, पार्टिसिपेट भी करेंगे, साइट सीन भी देखेंगे। अभी यूपी सिंह जी ने बता ही दिया कि भुवनेश्वर इज ए सिटी ऑफ द टेम्पल। इन्होंने जिक्र नहीं किया सन टेम्पल का, इसलिए मैं सन टेम्पल भी कोई देखना चाहे तो देखना चाहिए। कोणार्क वो भी उड़ीसा में ही है, पास में ही है, ज्यादा दूर नहीं है। कोई साइकिल यात्रा भी निकालते हैं कुछ टू प्रोटेक्ट इन्वायरमेंट, कुछ निकालते हैं यहाँ के लोग। मेरे को क्या, मैं संसद साइकिल से जाता हूं ना, तो मेरे को बुलाया था एक बार। मैं साइकिल मैन के रूप में भी जाना जाता हूं। अभी कोई एंकर कह रहे थे मैं गाता भी हूं, गाने वाला भी हूं, खैर, लेकिन साइकिल वाला भी जाना जाता हूं। तो मुझे यहां बुलाया गया था, भुवनेश्वर से पूरे साइकिल पे चलते हैं लोग, टू क्रिएट अवेयरनेस फॉर द एनवायरमेंट। ये समुद्र के तट के किनारे किनारे साइकिल से। ये सब इन्वायरमेंटल इशू भी पूरे वर्ल्ड में है। तभी तो पेरिस एग्रीमेंट हुआ टू रिड्यूस कार्बन एमिशन। ये सब इशू रहेंगे ध्यान में। ये सब इशू, किस कंट्री ने कौन सा अच्छा काम किया वो हम शेयर करें, कैपेसिटी बिल्डिंग में कौन आगे बढ़ा वो हम शेयर करें, हम सीखें, लर्न करें। खाली यहां कॉन्फ्रेंस में आगे किसी ने बहुत अच्छा भाषण दे दिया, किसी ने बहुत अच्छी टेक्निकल राय दे दी, और हम यहां पे मोबाइल में बिजी रह गए कि ट्विटर किसका अच्छा चल रहा है, तो फिर कुछ नहीं होगा साहब, फिर कुछ नहीं होगा। इसलिए पूरा अटेंटिव रह करके हम इस कॉन्फ्रेंस को सीखें। बहुत इंपॉर्टेंट कॉन्फ्रेंस है। मुझे पता है कि त्रिवेंद्रम में शायद मैंने इस कॉन्फ्रेंस का इनॉग्रेशन किया था ना। कुछ लोग थे ना उसमें, नहीं थे? है? थे ना। तो फिर उसके बाद से कितनी यात्रा आगे बढ़ी कुछ यात्रा। मुझे बताया गया है कि रिपेयर एंड रिहेबिलिटेशन में 198 डैम्स का प्रोग्राम हाथ में लिया था, वो 75% तक पूरा हो गया। हो गया क्या? हो गया? धीरे धीरे बोल रहे इसलिए कम हुआ है दिखता है। हो गया? हो गया तो बहुत अच्छी बात है। और बाकी आप कह रहे हो कि ताली तो बजा दो अगर हो गया। 75% तो बहुत बड़ा अचीवमेंट है। बाकी मुझे बताया गया कि 2020 तक पूरा कर देंगे, और 2020 में ही आई कॉल्ड एक कॉन्फ्रेंस कर रहे हैं। यहां पे एक बड़ा इवेंट कर रहे हैं, वो भी एक बहुत अच्छा इवेंट होगा। इसमें मुझे बताया गया कि करीब 1200 डेलीगेट्स आएंगे उसमें। तो बड़ा एक इशू, अभी यूपी सिंह जी ने एक इशू छेड़ दिया, उसको कह करके मेरी बात को समाप्त करूंगा कि डैम सेफ्टी बिल दैट इज इन पार्लियामेंट, वेरी राइट, दैट इज इन पार्लियामेंट, बट द लास्ट सेशन ऑफ द पार्लियामेंट इज एंडेड yesterday. Now it is, I think, in 17th Lok Sabha, we can discuss and deliberate. This matter is over now. We have to again introduce in the parliament. We have introduced, I think I have introduced in parliament. But one MP from Odisha, he has raised the objection. जैना साहब ने कुछ कहा होगा। अब यह भी एक इशू है आपके इंटरनेशनल कॉन्फ्रेंस का। ऑस्ट्रेलिया में क्या हो रहा है डैम को लेकर के, वेदर इज ए सेंट्रल सब्जेक्ट और स्टेट सब्जेक्ट। इटली में क्या हो रहा है, कनाडा में क्या हो रहा है, शेयर करिए नॉलेज। अगर डैम किसी एक स्टेट में है तो स्टेट इशू होना चाहिए। अगर डैम अगर 4-5 राज्यों की इकोनॉमी को चेंज करने वाला है तो वो एक राज्य का कैसे हो सकता है जी? हो सकता है क्या, बताओ मेरे को। जैसे भाखड़ा, अब श्रीनिवास जी भी कह रहे हैं ये समस्या, ये मुझे बता रहे थे एक दिन कि नदियां इसलिए नहीं जुड़ रही है कि राज्य है एग्री नहीं हो रहा है। यही है ना विषय। कब तक इंतजार करेंगे जी? क्या है नदियां जुड़ने का विषय पता है? सबसे पहले डॉक्टर बी आर अम्बेडकर, ही वॉज ए मिनिस्टर आई थिंक, or he was not a minister, I don't know, but he raised the issue in Constituent Assembly कि अगर इंडिया की आपको ड्रॉट की प्रॉब्लम को दूर करना है, आपको फ्लड की प्रॉब्लम को दूर करना है, तो आपको रिवर को इंटरलिंक करना पड़ेगा। इन 1949, यही है ना, सही बात है। आप तो आजकल देख रहे हो इसको। डॉक्टर बी आर अम्बेडकर raised the issue in the Constituent Assembly. You have to do it. Otherwise the drought and the flood problem will be remain in India. उसके बाद अटल बिहारी वाजपेयी, उनको तो जाना ही जाता है नदी जोड़ने के प्रोग्राम से। फिर इकोलॉजी वाला बीच में इशू आ गया। फिर हम 2019 में खड़े हैं। कहां 1949, कहां 2019। तो कोई एक सब्जेक्ट हम लेते हैं और उस सब्जेक्ट में चलते ही रहते हैं। कब तक चलेंगे जी? है? चलते ही रहेंगे क्या? नहीं, 2022 तक कुछ करना है। ये एपीजे अब्दुल कलाम साहब ने क्यों सोचा था कि इंडिया हैज ए पावर, इनहेरेंट पावर टू बिकम ए सुपर पावर बाय 2020। सोचा था क्या? कहा ना क्या? एपीजे अब्दुल कलाम साहब ने कहा या नहीं कहा? बताइए मेरे को। क्यों कहा था? उन्होंने इनहेरेंट पावर को देखा इंडिया की, कल्चरल पावर, इंटेग्रिटी, इंडियन मूवमेंट, साइंस एंड टेक्नोलॉजी, ये सारी चीजों को देखा, यूथ पावर, सब देख के ही कहा, नेचुरल रिसोर्सेज, ये सब देख करके ही एपीजे अब्दुल कलाम साहब ने कहा इंडिया कैन बी ए सुपर पावर बाय 2020। हम 2019 में 2022 भी आने वाला है और 2022 भी आने वाला है। क्यों इंपॉर्टेंट है 2022? Why 2022 is important for India? Huh? Yes, the India will celebrate the 75th year of independence. तब तक तो हम सुपर पावर बनेंगे या नहीं बनेंगे? है? बनना है क्या? बनना है तो फिर डैम सेफ्टी में बहुत जोरदार काम करना पड़ेगा आपको। जितना भी शेयर आपका नॉलेज है उसको शेयर करिए, कंस्ट्रक्टिव अप्रोच रखिए, पॉजिटिव अप्रोच रखिए। कोई भी क्या होता है, मैं थोड़ा सा एक आपने शादियां देखी क्या? शादियां, शादी सबकी हुई होगी ना। उसमें एक फूफा होता है। फूफा जानते हो क्या होता है? फूफा जानते हो क्या? कुछ महिलाएं हंस रही है। फूफा होता है जी। अब वो शादी होने लगती है तो वो फूफा आकर के, अब फूफे की इंपॉर्टेंस नहीं है उस घर में, तो भी आकर के टांग अड़ाता है, जी ये ऐसा नहीं हो रहा, जी ये मिठाई अच्छी नहीं बन रही। तो कौन पूछ रहा है अभी आपको? अननेसेसरी आकर के मिठाई अच्छी नहीं बन रही है। फूफे की इंपॉर्टेंस खत्म हो गई, नई जनरेशन आ गई, जमाई आ गया घर पे जिसको सन इन लॉ बोलते हैं, फिर भी फूफा टांग अड़ाता है। तो हमारे दफ्तर में भी कुछ फूफा है भाई साहब, ध्यान रखो, उनको पहचानना पड़ेगा। ये जो फूफा टांग अड़ाता है ना, उसको साइड में करो। बोला अभी आपकी इंपॉर्टेंस खत्म हो गई भैया, हम जाएंगे बारात में। ऐसे ही ताव देते रहता है फूफा जी। मैंने कई जगह देखा, कई बारातों में फूफे बारात को बिगाड़ देते हैं, मिठाई अच्छी नहीं बन रही है, इसने कपड़े अच्छे नहीं पहने, ये डीजे कैसे बज रहा है। मैंने कहा आपको करना क्या यार, बारात में चलो ना। तो ये बारात चल पड़ी है भाई साहब। ये देश की बारात 2022 तक जो यंग जनरेशन है इंडिया का, ये भारत को सुपर पावर के रूप में देखना चाहता है। इसके लिए डैम सेफ्टी भी बहुत इंपॉर्टेंट एक इशू है, एक एस्पेक्ट है। इसमें सब लोग जो आज इस कॉन्फ्रेंस में आप अटेंड हो रहे हो, उसकी पूरी तैयारी करें। मुझे लगता है इसी पॉजिटिव सोच के साथ जब जाएंगे तो जो कल्पना की थी अटल बिहारी वाजपेयी ने एक बार कि 21वीं सदी भारत की होगी, ये कल्पना कोई साधारण कल्पना नहीं थी अटल बिहारी वाजपेयी की। 1 जनवरी 2000 व्हेन ही वाज ए प्राइम मिनिस्टर, तो एक पत्रकार पहुंची, लेडी पत्रकार, अटल जी क्या कर रहे हो? उन्होंने कहा मैं सूरज की पहली किरण देख रहा हूं। सन टेम्पल है उड़ीसा में, इसलिए कह रहा हूं, मैं सूरज की पहली किरण देख रहा हूं। बोला क्या देख के क्या सोच रहे हो? तो अटल जी क्या हिस्ट्री को भी जानते थे? उन्होंने कहा नो 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 नो, मुझे देखने दीजिए एक बार, उसके बाद आपसे बात करूं। जब किरण देख के आए, आधी घंटा लगाया। बोला अटल जी क्या? बोला 21वीं सदी, वो हिस्ट्री को जानते थे इसलिए कहते थे 21वीं सदी एशिया की होगी। उन्होंने कहा 1 जनवरी 2000 को बड़ी डिबेट हुई, कैसे कह दिया अटल जी ने, कहां से होगी एशिया की? चलता रहा। और अब धीरे धीरे ये कौन तय करता पता आपको? कोई हम लोग तय नहीं करते हैं। हिस्टोरियन कॉन्फ्रेंस, इंटेलेक्चुअल क्लब, ऐसी कई संस्थाएं जो मिलकर के तय करती है सदी किसकी होगी। जब उन्होंने तय किया कि 19वीं सदी यूरोप की थी, लीड यूके ने किया। 20वीं सदी नॉर्थ अमेरिका की थी, लीड यूएसए ने किया। अब ये कई दिनों से कह रहे हैं, कई दिनों से। पहले उन्होंने 10 साल ऐसा भी कहा कि ये अफ्रीका एशिया की कॉमन कंबाइंड सदी होगी। अब वो नहीं है, अब नया थॉट है। सारे यूरोप के जितने भी लोग हैं, जितने भी देश हैं, उनके राइटर थिंकर ये कह रहे हैं कि 21वीं सदी एशिया की होगी। एशिया में 4 देश कंपटीशन में, कौन कौन से ध्यान है? कंपटीशन तो रहेगा, नॉर्थ अमेरिका में भी रहा था कंपटीशन, कनाडा के लोग बैठे हैं। यूरोप का भी था, यूके से फ्रांस और इनका भी कंपटीशन था, यहां भी रहेगा। कौन कौन से 4 देश है जी एशिया के जो कंपटीशन में है? सदी एशिया की होगी। इट इज ए डिसाइडेड नाउ, ऑलमोस्ट डिसाइडेड। जापान, चाइना, इंडिया है, अरे कोरिया नहीं है। उसमें क्या चक्कर है कि ये जो रूस है ना, रशिया, ये 85% एशिया में और 15% यूरोप में, तो इसलिए इसका नाम देते हैं वो यूरेशिया। तो एक आपका यूरेशिया, एक जापान, एक चाइना और एक इंडिया, ये 4 देश कंपटीशन में हैं। और इन चारों देशों में लीड कौन करेगा? देयर इज ए 10, 15 parameter. One parameter is economy. Second parameter is democratic setup. तो कुछ लोग कह रहे हैं चाइना ही लीड करेगा. मैं आपसे पूछता हूं, अगर डेमोक्रेसी के पैरामीटर में नंबर देंगे तो चाइना को कितना नंबर देंगे? 100 में से इंडिया को कितना देंगे जी? बताओ मेरे को. उधर 0, इधर काफी मिलेंगे. डेमोक्रेटिक सेटअप तो हमारा है. अच्छा ये बताइए, फैमिली इज आल्सो एक पैरामीटर. क्या फैमिली इंडिया की कमजोर है, चाइना की आगे है क्या? कल्चर इज आल्सो पैरामीटर. क्या इंडियन कल्चर कमजोर है, चाइनीज कल्चर आगे है क्या? खाली इकोनॉमी में अभी चाइना आगे है. तो ये जो डैम सेफ्टी कॉन्फ्रेंस है, ये इकोनॉमी को आगे बढ़ाने वाला बड़ा पैरामीटर है. अगर आपने इकोनॉमिक साइज इंडिया की, हम 6ठी इकोनॉमी बन गए वर्ल्ड की, पता है ना आपको? हम 6ठी बन गए, 5वीं में प्रवेश करने वाले. जैसे हम तीसरी दूसरी में आएंगे. अच्छा सदी भी कोई अभी 2019 में ही डिसाइड हो जाएगी, ये भी जरूरी नहीं है. 1945 तक सदी यूरोप की थी, लेकिन जैसे ही नागासाकी और हिरोशिमा में बम पटकने के लिए इंग्लैंड ने अमेरिका से रिक्वेस्ट की कि आप बम पटकिए, नहीं तो जापान ताबे नहीं आ रहा, मान नहीं रहा हमारी. तब जैसे ही बम पटका तो वो सदी शिफ्ट हो गई नॉर्थ अमेरिका. इंग्लैंड ने भी बहुत रिक्वेस्ट की, साहब सदी हमारी मान लो. बोला नो नो, अब नॉर्थ अमेरिका में गई. 1945 में शिफ्ट हुई. अभी तो 2019 में, अभी बहुत समय. सदी एशिया की होगी, ये तय है. इसको लीड कौन करेगा, ये आप पे निर्भर है. आपका मतलब ऐसे टेक्नोक्रेट, प्रोफेशनल जो इंडिया के बारे में समझते हैं, जिनके मन में ये प्रेम है कि भारत को आगे बढ़ना चाहिए, भारत को सुपर पावर होना चाहिए. क्या हम एपीजे अब्दुल कलाम साहब को सैल्यूट नहीं कर सकते, जिन्होंने कहा 2020 में इंडिया सुपर पावर बनेगा? क्यों सोचा? क्या हम अटल बिहारी वाजपेयी को नहीं कह सकते, जिन्होंने 1 जनवरी 2000 को कहा कि यह सदी एशिया की होगी? तब किसी ने भी नहीं माना था, और अब सब मानने लग गए हैं कि यह सदी एशिया की होने वाली है. भाई साहब, एशिया की होने वाली है, और इंडिया इसमें लीड करे. आप सब साथ होंगे या नहीं? बोलिए, साथ हो ना? तो मेरी बहुत बहुत सफलताएं, शुभकामनाएं. थैंक यू वेरी मच.
आपका हार्दिक धन्यवाद. आपके अभिभाषण, उपस्थिति, संबोधन और पारस्परिक विचार विमर्श के लिए हार्दिक धन्यवाद पुनः से. आपकी उपस्थिति यथार्थ में प्रेरणा का स्रोत है, और इसमें कोई दो राय नहीं कि आपके मार्गदर्शन ने बांध पुनर्वास और सुधार परियोजना के तहत आयोजित बांध सुरक्षा पर इस अंतर्राष्ट्रीय सम्मेलन में नया प्रोत्साहन जोड़ा है. इसके लिए हम कृतज्ञ हैं. मैं अभी निवेदन करूंगी जल संसाधन, नदी विकास और गंगा संरक्षण मंत्रालय के सचिव श्री यूपी सिंह से कि वे हमारे माननीय राज्य मंत्री को एक मोमेंटो प्रस्तुत करें. धन्यवाद ज्ञापन के लिए. I would now request Secretary, Ministry of Water Resources, River Development and Ganga Rejuvenation, Government of India, Shri U.P. Singh, to kindly present a memento to our Honorable Union Minister of State for Ministry of Water Resources, River Development and Ganga Rejuvenation, Shri Arjun Ram Meghwal, as a memento. Thank you. And now I would request Shri P.K. Jena, Principal Secretary, Odisha Water Resource Department, to kindly propose the vote of thanks.
Esteemed Minister Shri Arjun Ram Meghwal ji, and my colleagues in the dais and friends, it's my honor to propose a vote of thanks to our honorable guest, who along with being the Minister of State for Water Resources Development, is also the Minister for Parliamentary Affairs. And yesterday, though he was very keen to join us, he couldn't, because yesterday was the last day of the last session of this Parliament. And as the Parliamentary Affairs Minister, he could not have left the Parliament. That is why he, in spite of his busy schedule, he has to go back to again Rajasthan today and reach there early at the earliest. He still decided to join us, and sir, we are grateful to you for that, sir. Sir, Here we have about 700 plus dam professionals from India and abroad, and since yesterday we are discussing, debating various issues about the dam safety. We, the dam professionals, we also agree with you that it's very difficult not only in India but also in other countries to have new dams because of various complications, complex issues involving forest, environment, resettlement, rehabilitation, land acquisition, all these things. It's very difficult. Not that we can't do it, but it would take a lot more efforts than what we used to face in earlier years. The displacement of people from the reservoir areas is a very sensitive issue, and it needs to be handled with much care and caution. And there are excellent examples across the world, also in India. We have to learn from each other, and certainly this requires much larger debate among policymakers, implementers and the engineers, and that would of course be another occasion to have a big conference like this to debate for 2-3 days and find some good solutions which might work in our context or in some other context. Sir, here we are discussing about when we know that new dams are not possible to be constructed or will be very difficult to construct, how do we harness our existing dams in a manner that at least we serve our countries for next 30 years, 40 years, 50 years. In that connection, dam safety is very important. It is not only about structural safety we are discussing here. We are also talking about the non-structural issues involved, particularly the governance framework around dam management, maintenance and operations. And we are having leading experts from different parts of the country who are sharing their experiences, and this is emerging as a good platform for the Indian engineers and academicians and dam practitioners from India to get access to various knowledge resources that is available from across the world. This is an excellent platform to develop good network with international institutions and individual experts. So that way, this DREAP program supported by World Bank and led by CWC with the support of the states is giving an opportunity to all the states to review their own dam safety organizations, to strengthen their capacity and capability so that India can be a lead example in the country to at least many of the countries in terms of better management practices for safer dams for the world. Sir, your presence has certainly given us a lot of encouragement to think about the issue much deeper, and I am sure all my colleagues from India and outside will think more seriously and commit ourselves for safer dams in the world. Thank you, sir. Along with that, I thank all my colleagues in the dais. Thank you.
Thank you, Sri P.K. Jena, Principal Secretary, Orissa Water Resources Department, for proposing the vote of thanks. Ladies and gentlemen, with this we would be concluding this special session on the interaction meeting with Sri Arjun Ram Meghwal. Before we conclude, a small announcement. We found an Aadhaar card copy here which belongs to Miss Shruti Kumari. So if you've lost it, please contact one of us for your copy of Aadhaar. And we had given the feedback form. We would request all of you to kindly leave the feedback form, filled up feedback form on your seats. Again, the lunch for all the dignitaries, international delegates, session chairman, session co-chairman, and speakers have been arranged in the banquet hall of the NX building. So we request them to kindly have their lunch in the banquet hall, and the other lunch arrangement is in the exhibition hall. With this, we conclude. We thank all the distinguished dignitaries on the dais for their valuable time and presence, and we thank all of you for your very interactive and patient hearing. Thank you so much. We invite all of you to kindly join us for lunch now. We would be starting our next session at 2:15. So, and I request all of you to kindly be seated few minutes before 2:15 so that we can start our next session on time. Thank you so much. Enjoy the lunch and have a great time. Thank you.